Hello everyone, Walchand College of Engineering Sangli and Elisa presents you the tutorial series on microprocessor peripherals and interfacing, that is 8051 basics, architecture, programming, interfacing, etc. This is fourth lecture in this series and the topic is 8051 programming, and I'm your friend Rishikesh Nikam, facilitator for this video. In this video, we are going to see some basic things in 8051 programming. Simple LED flashing program, its logic and execution, also for explanation, its circuit diagram, and simulation in Kyle and Proteas. So let's get started. Basics for 8051 programming. 8051 microcontroller is a programmable device which is used for controlling purpose. The programming language which we are going to use for execution in Kyle and Proteas is embedded C, which is basically the C language only. Like in C language, we denote data types integer by int, character by char or unsigned char. In same manner, we use those in embedded C. Also, conditions like if, else, while are used in exactly the same manner. So let's move on to the next topic, which is a very important one, a program for LED flashing. You can see first line, which is hash include reg51.h. It is special function register declaration for intended 8051 derivative. Then we write the main code in void main. Then unsigned characters I, J, K are defined. At first, we give value 0x00 to P1 port. That is, all LEDs at P1 port will be at off mode first. Then in loop, we give delay for 1 second by using our pre-declared characters I, J, K. You can see the values given for I, J and K. They are given in such a manner that it produces the delay for 1 second. Thus we saw the code for toggling the LEDs at port 1. Now we can see the circuit diagram. We have used only port 1 for 8051 microcontroller, to which ULN2003A is attached. ULN2003A is an array of 7 NPN Darlington transistors capable of 500 milliamps and 50 volt output. This is known for high current, high voltage capacity, and its typical usage is in driver circuit for relays, lamp and LED displays. 7 LEDs are connected through resistors in parallel from DC voltage source. You can also see the typical crystal and reset circuit here and here. Now we move forward to see the simulation of this program in Kyle Microvision Fire and in Proteas. Now we move forward to see the simulation of this program in Kyle Microvision 5 and Proteas. So I have opened Microvision 5. So I'll click on new project, then give some name to it. Then for 8051 microcontroller, we use 89V51 here and D2 in it. So I'll click on the button OK. Yes. So I'll take a new file. I'll paste our previous code in here, which I've just pasted. I'll save it by giving some name .c. So okay, save. Now I will add this file to this source group by clicking on add existing files to group. So now it has been added. Now I'll build the target for this. So you can see there are 0 errors. Now options for target 1. So this is very important step. Here we have to create hex file to be burnt in Proteas. So click on create hex file in target in output. Also we click here, then say OK. Now we build it again. So here are 0 errors. So now we see and execute this code. So clicking on peripherals, we have selected port 1. So now you can see it is toggling. Yes, it is toggling. So the program is working fine. So this is with Microvision Fire. Now we are going to see the Proteas simulation for our file, our program in Proteas. So I've already created the schematic in Proteas, as you can see, similar to the circuit diagram. So when we click on the microcontroller, it asks for the hex file. Previously on Microvision 5 we have already created the hex file, so I'll just add it here. So it has been added. So I'll just play. So now you can see after every 1 second the LEDs are glowing. They're being on and off after delay of 1 second, and hence we have successfully completed the simulation in Proteas. We just have seen the program and simulation for toggling all LEDs connected to port 1. But if we want to flash just one LED at any pin of some port, then we can refer to following program. In this program, basically everything is same, but just we define pin 0 of port 2 to be toggled by command sbit LED P2 0. SBIT stands for single bit. Similarly, delay is given and LED is toggled. Here you can see the delay. So this is the circuit diagram in which it is clearly shown the LED is connected to the port 0, pin 0 of port 2, and then toggled. Thank you for watching the video. Hope you liked it. For suggestions, visit valchan.elisa@gmail.com and like us on www.facebook.com/WCES Elisa. Thank you again.